Sir. Hello, am I audible?
Good evening, sir. Good evening.
So, sir, let's start day 2 class for CCNP Enterprise. And you can just, give recap the yesterday class for 5 minutes and then you can continue, please.
Just allow me a moment, sir. I'm just bringing up my system.
Sure, sir, sure.
Hello, everyone. This is Amit. You already know. And this is your day 2 of CCNP Encore plus NRC bundle. Like Fortinet is also there in this bundle, but initially I'm talking about Encore and NRC. If their people will be more interested, then definitely we'll be doing. We are going to do that as well. Now that depends. If you guys are interested in the same batch or you want to go with another, that is okay. That is customizable, definitely. Point is, my system is up. Just allow me a moment, everyone. Let me take access of that system. Windows and I think I did not share my screen, right? So let me share it. Hey guys, may I listen something from you all? Like if I'm audible.
Yes, sir, you are audible.
Good, Poonam, thank you. Hi Javed, hi Akash, hi Poonam Sagar. Welcome to the class, guys. So let me share my screen and we'll be starting from the same location we left yesterday. So guys, this is that screen. I hope everyone is able to see my screen. If not, kindly confirm here. Okay, you can ask. I'll be again sharing that. Okay, so let's start. See all the packets where they are stuck in the same position. So let me open the notepad. I don't know why notepad is not there, but I think notepad I saved for you all. So let me get that. Here is that one. Yes, day 1. Exactly, guys. So what we did till yesterday, till there, just me take it. We were here, right? See, guys, it has 10.1.1.1/24. It has 10.1.1.1.2/24. Let me go here and also let me give here IP. I think you guys are pretty much aware about how to configure IPs on interface of your router. So if you don't know, so I'll be showing you like this is the way how to do the configuration. But once that particular section will be started, then you will hear about that in more detail. Now this is up. That's fine. So let me make it really very quick. That's fine. Good. Now what we did till yesterday was I was pinging PC2 on my PC1. Like I was taken this particular thing, see? Like this. And I tried to ping to whom? To PC2. So let me first delete everything. Then I'll be starting it again. As Sachin sir suggested. Okay. So let me also check here show MAC address table. It has entry. Clear MAC address table dynamic. Good. Let me check it again. I am entering commands, these commands unnecessarily here. Why? Because I am just wanting you guys to see that what command I am typing here. But don't worry. If anyone is there who is wondering, don't know. So once the topic will come in this particular course, you are going to see everything from scratch. You not need to worry about that. Now I think we can start literally. So what I told you yesterday, let's suppose this PC1 I am on, I took its CLI access, command prompt access, and from there I'm pinging, like in general human language, like I'm saying hello. To whom? To PC2. So what are the things that will be happening in the backend that we were discussing yesterday? So now let's continue, guys. Thank you. So what first thing it will do, your PC1, if you go here, then you can see what we have discussed yesterday. In step 1, see, PC1 wants to talk with PC2. On PC1, it will take its own IP, PC1 IP that is 10.1.1.1, its own MAC address that we took yesterday. Like again, today we can check, no issue. So let me start it from very scratch. So step number 1, what it will do? If we want to ping PC2, and who is this PC2? This one from PC1. Who is PC1? This. So what are the steps? Step 1. I am just mentioning here A. And what is that? As PC1 wants to ping PC2, so it will initiate, you can say, or initiate a process that will be handled by whom? ICMP, guys. Like once you are pinging, then ICMP will take over, and ICMP is the protocol who works in backend of ping. Okay. So ICMP is a layer 3 protocol. I'm saying layer 3, it is writing layer 2. Okay. Okay, so ICMP will do what, guys? Now ICMP will do this part. It will take source IP, of PC1, that is 10.1.1.1. It will take destination IP, that is 10.1.1.2. You are with me, everyone? And after that, it will take source MAC, PC1's MAC. And how you will check PC1's MAC? Anyone remember how will you check PC1's MAC? So you will go on PC1 and will run a command that is called ipconfig/all. I entered wrong command, guys. Here is your physical address. Where is that? This one. This one is the IP address. One sec, guys. Where is that copy one has gone? No issue. So it will take source MAC as like this. Why I'm putting here? And destination MAC. For destination MAC, now will be going from here. For getting destination MAC, PC1 will check in its ARP cache for IP MAC mapping. What does that mean? That means ARP is a protocol that is known as address resolution protocol. What it does, guys, it actually create mapped entry in its ARP cache, so that once any user is trying to go and want to talk with another user, that user who is trying to talk with another user can take help of this ARP cache, and it can go there and can collect the MAC address with the corresponding IP address, so that it can make this communication a success. You're getting it? Why? Because we are nowadays, literally most of the time, you are seeing whatever technology, that is Ethernet technology in backend. So in Ethernet technology, to do proper communication, we literally need two type of addresses, like two addresses, not two type of addresses. First one is the IP address, that is the logical address, that is unique identity of any system host user, by whom that user, that PC, that host can be recognized in your network. MAC address is also a type of address that is hard coded on your NICs, on your NIC, once you are purchasing any device. So what is the MAC address? MAC address is literally your physical address, that is not we can't change that address, that is already fixed, and this is the static address. And what about the IP address, guys? IP address we consider sometimes, not consider. Actually, this is logical address. Like, this can be changed. What does that mean? That means your PC can get any IP address, right? Like, it is changeable. It is dynamic. Are you with me, everyone? You're understanding? Let's suppose you are using your PC and you are connecting with Wi-Fi. So one access point will give you one type of IP, like one IP address. It doesn't mean once you are going to some other Wi-Fi access point and you are connecting your laptop using that particular access point, you will get the same IP. No, you will get another IP, or it might be you can get the same IP. It means what? It means your IP address can be changed. It is dynamic, but your physical address, your MAC address is hard coded. That is not changeable. Getting it? So later on, we'll be talking about more about that. No need to think so much about that. Uh, don't give so much overhead on your head. Okay, just let's go as it is. So what it will do? Now PC1 will do what? PC1 will do, will check in its ARP cache for IP MAC mapping. Now let me show you the result. What is the result there, guys? So once, how will it check? What is the command of checking that? Command is ARP A. Tell me, is there any entry you are able to see? No entry found. What it is saying? It is saying no entry found. Because it is saying no entry found, now you can see. Because PC1 does not get any mapping. For whom? For destination MAC. And destination MAC, who is that particular person whose MAC we need? Destination IP MAC actually you are there to get. Like, this is 10112. We were searching there for this particular IP's MAC address, but we did not get that. So where we checked, guys, I'm just asking, in what table that is being checked now? Anyone? I'm asking, your PC1 checks that MAC address thing where? In what table? Or in what cache? Is that MAC address table, or was that ARP table or ARP cache? Tell me. Yeah, I want to hear from you all, if you are understanding it or not. Hi Harish, you are here. Good, good. Happy to see you. Okay. Guys, you're getting it, what I'm saying? I said, for getting the MAC address of 10112, your PC1 went where? Like the location, what you will be calling that location? What is the name of that location? Yes, Poonam.
Switch Mac. Sorry. Switch Mac table.
So actually right now we are here on the PC1 only. Yes,
Okay.
Poonam, I'm saying right now we are only on PC1. We are everything we are talking now. That is only on PC1. Till now, anything is not left from here. Everything is like we are stuck here only till now. On PC1 we are right now. So here there is a ARP cache, that is sometimes we call them ARP table as well. So once you are going and seeing any host that supports layer 3 addressing, that certainly will have ARP table or ARP cache. So what is that? ARP cache is a location where your IP and MAC address mapping any host can get. Let's suppose in our scenario, 10111 wants to talk with 10112. Then where it will get that particular MAC address of the 10112? Definitely in the ARP table, right? And why do we need that particular MAC address? Because in Ethernet technology, we need two address, IP address and MAC address. IP address your PC already knows. Why? Because we as an administrator, we gave that IP our PC1. Like PC1 know about its own IP, own MAC and destination IP, but it doesn't know MAC address. And from where we got that checked? From the ARP cache of PC1. Are you getting it now? Is that fine?
Yes.
Others? Guys, you're finding it well? Okay. So there is no entry. See, once I'm running this command on PC1, it is saying no ARP entry is found. ARP entries means what? ARP entry means the entry means mapping of IP with MAC. That's it. Because PC1 does not get any mapping for 10112. Now ARP will take over and generate an ARP request to get the MAC address of 10112. So from where your ARP request will be generated. This is the ARP request. And this one I am considering here point number 2. Okay. And what will happen in the ARP request, guys? It will match the source IP. It will take the destination IP. It will take the source MAC that is already known. It will take the destination MAC as broadcast. Okay. Source MAC is this one. Source IP is, destination IP is, okay. This will look like this. So now to whom it will be sent? ARP request would be sent out from the port FA0. Okay. Why I am saying FA0? See, this is here connected. Okay. And now who will receive this? And it will be reach to switch 1. Now, what switch will do now? Step number 3, guys. Once switch 1 received the frame, you are with me, everyone? Frame, then switch will follow below steps. Like what? Once switch will get that frame, what it will do? It will follow below steps. Step number 1. And what is that? That is, in this frame, switch will check destination source MAC field and match with its own MAC address table. Why it is matching this with its MAC address table? Because this is the way how your switches learns MAC address. Okay, this is the concept, literally very important concept. Once you will be going for any interview, 100%, I will not take guarantee, but most of the time the people will ask you about this particular part, like how switches literally learn MAC addresses. So this is the literally the very wonderful way. Once your switch will get any frame, whatever interface it is getting that, first it will check the source MAC field of that frame, and again it will take that MAC address and will go in its MAC address table and will do the tally. Like if there any MAC address like this available in its MAC address table. If yes, then that is okay. If no, then it will create entry. Okay? Are you with me, everyone?
Yes, sir.
Good. So, oh, one sec, guys. It is working very fast, you know. So let me remove it, otherwise I'll be not able to show you that concept. Show MAC address table. I just want to, oops, it learned everything. Clear R, not R, clear MAC address table. Show MAC address table. Now there is no, yeah, there is no entry. I'm just doing it intentionally, okay, because I wanted to show you once you have this particular type of scenario, how actually it works. So let me do it step by step. I'll be showing you. So first I am going here and I am trying to do this. See, first what is generated, everyone see, this is ICMP. And what ICMP will do, it will go before send, before sending anything out, it will go in it ARP cache and will try to get the MAC address for the destination. And who is the destination? That is 10112, because it is not getting, and it was supposed by ARP table to provide that address. So now ARP will take over that, and ARP will say to ICMP, can you please wait? Can you hold down for a moment? Let me go ahead and confirm the MAC address of 10112. And this is the reason ARP request is being generated. See, this is a second packet. Like frame, this is type ARP. Okay. And what will be the things inside? This one. Like there are so many other things also available inside, but this is the main thing that we literally are concerned here to understand. That is the main thing that we are trying to understand here. So in this frame, switch will check what? Source MAC field and match with its own MAC address table. If there is no entry, like in our case, there is no entry for this MAC in the MAC address table. Okay, till now no entry. So what your switch will do? Switch will create entry in its MAC address table. Okay, that's good. So after doing this, what now your switch will do again? Next, your switch will do this one. And what is that? Point number 2. In this frame, switch will check next. I am putting here next. In this frame, switch will check destination MAC field. And tell me guys, what is there in the destination MAC field? Yes, Harish Raj, Javed, Poonam.
Broadcast address.
Yeah, definitely this is the broadcast. Now, once your switch will check, this is the broadcast. This is a broadcast MAC address. Means what? Now switch will do what? Switch will do by default flooding for this, for the frame. But see how switch is really playing here intelligently. What it does first, it does check the source MAC first, okay? And it made entry also in the table. So let me move it ahead little bit. Once I will click on this, now see. Now let me show you. Earlier it doesn't had, right? Now it created entry, you see, on the F0x2 interface. And which entry is this? If you go in your notepad, then you definitely will see this. Let me show you actually. So if you are going here in your notepad, so what was there in the source MAC field? Source MAC field, it was there, this entry was there. Now if you literally want to validate that, now see, it took the same MAC address or not, see? right? This is in caps and this is in small. And which interface your switch receives that frame? On F0/2, and it associated with that particular port, isn't it? Next, in this frame, switch will check destination MAC, and destination MAC field has this 12 time F, means this is a broadcast message. Like broadcast is this is broadcast MAC address. Now your switch will do flooding for this received frame out of its all the interfaces except,
Source.
yes, except at what interface it receives that frame. With me, everyone? Except the interface it receives the frame. It received the frame. Now, in this case, what will happen? This frame, right? This frame, like that was ARP request. This frame will be sent out from interface. Now you can see here. Now just keep your eyes on it, guys. See. It is being sent from F0/1 and F0/3, right? Now I'm just writing it here. F0/1 and F0/3, correct? Yeah. Now what will happen next? That is the point number 4, guys. I hope step by step you are understanding, guys, right? Now, router on the top and PC2 below will receive the frame. Okay? And what will happen? Now let's talk about first router. What now router will do? Router 1, right? Once router 1 will get this frame, it will check. What it will check? See, guys, once
IP
now this is
address.
yes, Poonam. Let me tell you, actually, this is not that it will check. Wonderful. Now, this is the thing that this is the place where people struggle most of the time. So just focus here, everyone. So first it will, what first checked your switch? Once your switch receives the frame, what it checked first? Source MAC, yeah? Why I'm saying this? They are checking MAC only because see, where the traffic will be received at layer 1, right? The traffic will be received on using cable, right? The cable works at what layer of SI? Layer 1. So once that is done, then it will be shifted to layer 2, correct? On layer 2, MAC addresses will be checked, isn't it? Agree, everyone? Yeah, very simple stuff. Okay. If you're wondering, don't worry, I'll be mapping that particular part in our upcoming sessions. Like I'll be showing you a SI model and we'll definitely will map with that. Then you are going to get this 100%. Okay, so point is, after layer 1, it will be checked for layer 2. Once layer 2 information is checked on switch, it was checked for source MAC. But now once any other like host or the device that supports L3 things, once they are getting any particular thing like any frame, they will not check the source MAC. However, they will be checking the destination MAC. And what was in the destination MAC, guys? It was
Broadcast.
yes. Because this was broadcast, now your router 1 will receive this frame. What does that mean? Let me tell you, literally, people literally struggle here. Your interviewer literally want to check your understanding on this portion. Why it will receive that particular frame? Because that frame also can be sent to that router as well, na? But it is just checking the layer 2 information. That is the MAC address detail. So by just saying that it cannot recognize and identify like this particular frame is destined to me or someone else. How your router will come to know like this particular frame is destined to me or someone else? Once it will check IP address in that particular frame, right? So see here. Now what will happen? Router will receive the frame. Okay. What next? Might be few of you are not agreeing with me, but in this point now you are going to agree with me. Next, IP details will be checked. And router come to know that this IP does not belong to me. Hypothetically, I'm telling guys, okay? Like in general case, router will not do the exact thing that I'm mentioning here, but I'm mentioning this in general case. Like let's suppose here there was no router, here some PC was connected. Just like here PC2 and PC1 is there. Let's suppose here we have PC3 that have this IP 10.1.1.1.3. Okay, so in that case, but router actually does something additional as well. Okay, that I'll be telling in next upcoming, like I might be tomorrow. I'll be telling about that part as well. Just let it be some you know what is that suspense? Yeah. So next IP details will be checked, and router come to know that this IP does not belong to me, so it will drop the packet. Everyone is with me till here? Poonam, Akash,
Yes, sir.
Ramesh, yeah, you are with me?
Yes,
Till,
yes.
till here understanding, right? So what this was for R1. What about PC2? It was for R1, right? So I'm just putting it here. I think you are getting this particular notepad and the notes helpful, right? Like once you'll be doing revision or something, then you will have idea like how this thing is happening. So let me paste it here. And that is PC2. Once PC2 will get this frame, it will also check the destination MAC, because this is broadcasted. It can be intended to this PC2 as well. Now your PC2 will receive the frame. And what will happen next? Next IP details will be checked and PC2 come to know. Now tell me guys, once I am saying IP details, sorry, let me match here, like destination IP will be checked. Okay.
If IP address is match, then it will accept the frame and send
Yeah.
ARP response.
Yes, correct. So see, let me just one correction here, Poonam. So what happens once the MAC address is broadcast or multicast like that, or the MAC address is destined to the same particular user. Okay. So in the case of unicast MAC address, so now your host to whom that particular message is received will check the destination MAC as it is. It should be there as on its receiving interface. But in the case, this is the case what? Where the MAC address is broadcast, right? So not only this PC, even this frame will be received by everyone in this particular network, okay? At layer 2 I am talking. But once the layer 3 information will be checked, then they are going to know like if I need to drop this particular frame or I need to accept that and need to process further. Okay, because there was the broadcast, that's why R1 also received that particular frame, right? And it received that literally. But once it checked the destination IP details and it is saying, oh, this does not belong to me. Why? Because in the destination IP field, what is the detail available, guys? Yes, Poonam, tell me. There is this particular IP, right? Destination
Yes.
IP is 10.1.1.2. So that does not belong to R1. That's why it dropped here. Dropped, right? But it did not drop that at layer 2. It dropped that at layer 3. Okay. Is that fine? You're getting it? What about
Yes, sir.
PC2? Yes, Poonam getting it, na? So,
Yes, sir.
so once PC2 will get this frame, it will check destination MAC. And because this is broadcast, it will also receive. Even everyone will receive. This is the normal behavior at layer 2. Next, destination IP will be checked and PC2 come to know that this IP does belong to me. So, it will be accepted. Getting it? So,
Yes.
it will be accepted means what will be the next? Now, PC2 will check the type of or the request type. Okay. And what was the request type? That was ARP request, right?
Yeah.
So because this was ARP request, now PC2 will reply. And what it will send in reply? ARP reply. Now it will do what? It will do this. Source IP, it will use 10.1.1.2 because it is reply by the PC2, na? Destination
Yes.
IP would be like 10.1.1.1. But one thing literally very important, I want to grab your guys' attention here. Make sure to consider this. Before replying for the ARP, PC2 will create entry in its ARP cache. You are getting it? And how
Yes.
that will create? Let me show you. It receives, na? It dropped and it receives. See? Now let me show you here. ARP A. See? It created entry or not? But till now, no reply has been generated, isn't it? Now this is the verification, like you have proof as well of the same thing. So what it will do first? Okay. Now it will do what? Now it will reply it back. Okay. So now might be, this would be the good one. Like, let me put it here. After point number 2. Okay. Now this is the correct procedure actually. This is the normal sequence. Now it will do that part. Source IP this, destination IP. Source MAC, tell me what MAC it will use. It will use its own MAC.
Own Mac.
Exactly. IP config all, and this MAC address is here. Destination MAC, it already got that, right? Now tell me guys, from where it will get the destination MAC? PC2 will get destination MAC from where?
From ARP request frame.
From the, yeah, definitely. It took from there and it saved that in the ARP cache. Now it will go in its ARP cache and it will get that MAC address from there. Understanding?
Yes.
It will take it from here. And for destination IP 10.1.1.1, this is the MAC address and it will take and it will put here in the ARP reply. Very simple stuff, guys, isn't it? Getting it, everyone? Yeah. Now this will be sent to whom? This ARP reply will be sent to switch. Now tell me what switch will do again?
Learn the learn the MAC address of PC2.
Exactly. And how it will learn? By checking the source
But
MAC in the
source MAC.
frame. Oops, sorry, I'm just copying different thing. Wait, let me take that particular, that switch one was there, na? So, yeah, this one. Let me take all these steps from here. I think this will be good. Yes. Step number 5, yes. Now once switch 1 will receive the frame, switch will follow below steps. In this frame, switch will check source MAC field and match with its own MAC address table. Now what it will get in the MAC address table? Nothing, right? Because this MAC address right now that is received, it was not earlier in the MAC address table. So what it will do, because there is no entry for this MAC in the MAC address table, so it will do what? So it will create entry in its MAC address table. Are you with me? Yeah. So right now, is there any entry? Let me show you. Only one entry is there, isn't it? Correct? Let me send it that. It receives, yeah? Good. Now go and see. It created entry or not? Just right away. Are you with me, guys?
Yes, sir.
So here is the proof. Let me give it to you. Yeah, here is the proof. Next, what it will do? In this frame, switch will check destination MAC field and match with its own MAC address table. Now, in our case, what is the type of this MAC? Guys, this is 101, na? So this MAC address is unicast MAC and entry got matched. Isn't it? What do you say? Is that matched or not? So see how the ARP reply was looking like. The destination MAC is this, na? Now see, if there is any entry 6D89. 6D89 is there and that is attached to whom? F0/2 interface. Yeah, exactly. Now this time it is not going to flood that. However, what it will do? Because destination MAC is found in the MAC address table. Now switch will forward this frame out of the appropriate port. And what is the appropriate port in our case? That is F0/2, isn't it? See? Where the destination MAC address is attached on F0/2. So now switch will send that frame from where? See? Now next step, see guys. Yeah? Is that matching with the thing that I'm saying you? Or not? Tell me. Matching, yeah? So, step number 6, PC1 will get the ARP reply against the ARP request. And now it will update its ARP cache. You are with me, everyone? And
Yes, sir.
will supply MAC address to ICMP. Remember, first time ICMP got generated, it took the source IP, destination IP, source MAC, but once it went to the ARP cache, it was not getting anything there, right? Just one moment, everyone. Give me 1 minute, guys, please. I really sorry, guys, because time is the constant here and I'm taking your time. Sorry. So that is done. Okay. So till here following. Yes, guys. So now if you are going here, see, ARP is received, right? Once ARP is received, now further ICMP has taken over. So let me show you guys this one. Now if you'll go here, earlier it did not had any entry. You see here. But now if you are putting it like this, it has already entry. Got it? Now ICMP will be sent. Now tell me what will happen next. Yes. PC1 will get the ARP reply against the ARP request, and now it will update its ARP cache and will supply MAC address to ICMP. Now ICMP will send ICMP echo request. Like the hello name is known as echo request, okay? To PC2. Once I am saying PC2, that means 10112, okay? And switch will receive this. Switch will receive this packet on port number F0/2. I hope everyone is agreeing with me. If this PC will send anything, so switch will receive that particular thing on F0/2. Yeah, agree? Guys, am I audible?
Yes, sir.
Yeah, understanding it, right?
Yes.
Good. Now let me send it. It receives. Now tell me what switch will do. Switch has normal behavior. And what is that? If it will get any frame, first it will do what? Once it receives, it will go and check the source MAC field. And it will match that particular MAC address with its MAC address table. If entry is there, that is good. Then it will update the aging time of the MAC address table. But if the entry is not there, then it will create entry. Then it will go to destination MAC field. And on the basis of the MAC address availability, it will take forwarding decision. If that particular MAC address has MAC field has unicast MAC, then it is going to check, oh, where that particular MAC is connected with me. And from where it will check? From the MAC address table only. If that it found, then it is going to send that particular frame out of the appropriate port. But if it will not found, then it will do what? It will do flooding then. You're getting it? So what does that mean? That means, let's suppose your switch is getting a request in the destination MAC field. There is no broadcast MAC address. However, that is unicast MAC address. But that MAC address entry is not available in the switch MAC address table. Then your switch is going to do what? It will do flooding. Why? Because it itself doesn't know. That's why. You are with me? So that will happen only because of the switch. And why it will happen? There is a big reason. So what happen in normal cases, guys? ARP entry lasts more than your MAC address table entry. Let's suppose this user pinged to this user, that is PC2. So once the ARP is resolved, so this PC1 will save that entry for 4 hours. Getting it? Let's suppose this user has not did any communication, has not done any communication for 50 minutes or 1 hour. There is no issue. Because why? Because that ARP cache will have entry still saved, because that lasts for 4 hours. But in the case of MAC address field on switches, where your switch saves and it stores the MAC address details and attached interface with, it expires only within 5 minutes. Now see, 1 hour there is no communication, like your MAC address field information will be removed, right? Now he is sending, because it knows already who is that particular person, like 10112 MAC is what? From which ARP cache. Once this switch will get this type of frame, that is known as unknown unicast frame. Are you with me, everyone? That particular concept is known as unknown unicast frame. And in this case, your switch is going to do flooding. Okay? Getting it? Theoretical part only, guys. But you will be not able to identify, even user will not be able to identify that, because that will happen within fraction of milliseconds, that no one catch exactly. That is the something that works, that happens very fast actually, guys. But in the real scenario, this would not be the case. Why I'm saying, let me tell you. In the real environment, your PC will keep sending so many things every time, right? In its backend. So switch will not get this type of scenario, literally, believe me. But in general, if you want, if you are understanding this in context of technology, it can be done. Okay, good. So once your switch will get that, then what it will do? Point number 7. Switch will receive this and check again the same thing. Source MAC, entry found. Yeah, found. Good. Check for destination MAC. Oh, this is unicast and entry found. Now what it will do next? Switch will forward this packet out of the appropriate port. Now tell me, your ICMP was looking like what? Your ICMP was looking like this now. Now you can put it here. Like exactly not like that, but hypothetically I'm saying you. Like that is the information I'm giving you. As per that, that is correct. Not hypothetical, that is correct. Now your ICMP will be going like this, okay? I'm putting here ICMP. Okay. Sorry. Control C is the right. Switch will receive and it will send that wave where. Now tell me, what is the destination MAC field? The destination MAC address 00024AA16D89. Tell me, guys, what interface now your switch will forward that frame? Go here in the MAC address table and tell me. See here and match and tell me the answer. I'm expecting this answer from you all.
FA02.
Oh, sorry. Yeah, you are right. But let me make it change. You are right, but I am just going to make a change. Because this was not correct, actually. Yes, now tell me, at what interface it will exit this particular frame?
FA03.
FA03.
03.
Yeah, you got it. Good. F0/3. Fast Ethernet, you can say. No issue. F03 also you can say. Also, it accept the command as. Now, who will receive? Like this particular time, it is not going to send that to router as well. No, why? Because this is unicast. Let me show you. See, only to the appropriate port it sends that. Why it is able to send that? Reason is it had entry in its MAC address table. That was the big reason. Okay. Now see the same thing. It will receive the returning packet, and that it will check and again will send. In this way, now going on, everything will happen directly. 101. That is called unicast communication. Are you with me understanding this, everyone? Till here you are fine? Any question? Question time, guys. You can ask. पूछ सकते हैं आप लोग प्रश्न. Yes. Akash, Karan, Poonam, Ramesh. Any question, guys, you have? from this section, like how this packet flows within the network?
No, sir.
Good. So this was it only for today, guys. Tomorrow, what you are going to see, let me tell you first. So tomorrow we'll be seeing, let's suppose this PC1 wants to talk with this.
All clear.
Oh, good, good, good. That's good. Let's suppose this PC1 wants to talk with PC3. Now PC3 is where? PC3, if this PC1 wants to talk with PC3, then all that traffic should go for first switch, then switch will send that to R1, then R1 will send to that R2, then R2 will send that to this switch, then switch will again send that to PC3. So that would be the very big part, right? Now, that particular part will be more interesting, and that is literally very demanding concept that you guys will be asked once you are appearing for interview, or you will be benefited if you are working in your real environment as well. I hope you guys are finding it little bit helpful for you all. And if that is the case, please acknowledge at least, guys. Yeah. Akash, Karan, Poonam, Ramesh.
Yes, sir, all clear.
Yeah, you are getting it beneficial.
Yes, sir. Yes.
Good, good. So that was it for today, guys. We'll see you guys tomorrow. So initially this is happening for only 1 hour, but later on it will be increased to as per your convenience. Okay. If you are finding it well, okay, we can go for 2 hours, then I'll be extending the class for 2 hours. Don't worry. But initially, I'm not rushing actually. I want to make everything from scratch and step by step with slow speed. Okay.
Okay, sir. And thank you, sir.
Thank you so much. Okay. Who is this? Ramesh, right? Hi, Ramesh. Sachin sir, please take care for this. I think this is for you, this message. What is the enrollment
Sure,
process?
sure. I'll just discuss with him, sir.
Yeah.
Yeah. So, thank you for the class today, sir. We'll connect by tomorrow same time, sir.
Yeah, sure, guys. We'll see tomorrow packet flow in different network, guys. And that will be something advanced than today, okay? So there your more attention requires actually. Yeah. Thank you so much for joining, everyone.
Thank thank you, sir. Thank you, guys. Good
Have a
night.
nice day, guys. Bye.
Bye. Take care,
Thank you,
sir.
sir. Thank you so much.
Thank you so much, everyone.